All right, we are back here at the iVue Robotics Workshop for a late night session to review the Developer HP in front of us with the SIYI ZT6 thermal camera, as well as their MK32 controller with their video transmitter installed on the backside of the Developer HP. If you've watched some of our recent test flight videos, you have already seen this Developer HP take flight a few times now. Just wanted to go in through the top cover, show you what's inside, how it's all connected and set up. We may have to throw up some diagrams, or you may have to check back in our download section for diagrams for how this is all wired up if you're interested. Nonetheless, stay tuned and we will review how this is all set up. And if you have any questions, of course, feel free to leave those in the comment section down below. Starting out with the controller, I'm not going to necessarily hold this up to camera as we should be able to screen record it here. And I think I just swapped over to that. So there's two apps here on the home screen. There's the FPV app. And as you'll see, it's just a black screen right now. We need to power on the Developer HP. And once it boots up, you'll see the light on the controller go from red to green. And I skipped over actually turning on the controller, but I guess we can take care of that at the end as well. So here it's going to take another few moments. Shouldn't take too much longer. We should get a connection established any moment now. And here I go. I touched the screen. I don't think that had anything to do with the connection establishing. Nonetheless, we have the connection as you can see on screen. We have full touchscreen control over the camera in this application. We can also, as I mentioned in the video previously, actually get temperature readouts through this app as well. So if I hit the lock icon, temperature measurement is turned on, and now I can tap on the screen where I want to get a temperature measurement. And when you're side by side, you have to actually click within the thermal side of the screen. But now if I were to unselect that lock, I can rotate the camera. And now, for instance, we can get the temperature readout of one of the cameras recording this video. Now you can also take a photo in this application. You can start recording video as well. Oh, sorry. I ended up just clicking the wrong button there to capture photo and then record video. And then of course you also have the ability to zoom in and zoom out. Disregard the drone up on that shelf. You don't see that. You will notice that there's a little picture-in-picture window, although there's nothing inside of that. That's because we're in side-by-side view mode right now. So if I actually go down to this menu option here, if I go to mainstream, this is one of the ways to affect what's not just showing up in the SIYI FPV app, but QGroundControl, the drone control application loaded on this controller as well. Now there are other options. However, you know, we recommend QGroundControl. That's what we have the most experience with. SIYI, again, SIYI, they have their own ground control application. I don't think it's preloaded on this controller. I could be wrong. However, that could also be used, at least theoretically speaking as well. As you can see, this is also where you can change the settings to stream the video back in HD, which is 720p or 720p or full HD 1080p, and then of course there's the recording resolution. We just have that set to 720p right now, but you could also set that to 1080p. And then if you actually just go to main, you will see that you have 4K recording as an option as well. And now if I wanted to go to thermal, you don't have any of those options. It's just the native. I think this is 512 by 360, although it might be 480 by 360, but fairly high resolution for a thermal sensor nonetheless. All right, and you'll see the substream will default to whichever the mainstream isn't if you're not in side-by-side mode. And so as I was mentioning, you have the picture-in-picture window that you can shrink or expand in size, and then switch between just by tapping on the little picture-in-picture window. Alright, I am just going to show you really quick QGroundControl on this controller. And so you can see that the feed did switch in QGroundControl as well. Again, if you watch our most recent video, you'll see that we are using the side-by-side video view, but now we're just getting the thermal view as we set in the FPV app.
Stabilize flight mode.
And now that you saw the thermal feed only in QGroundControl, we're going to switch back to the main only feed, which if you watch our first videos with this Develop Air HP, you would have already seen. But again, just goes to show how easy it is to switch back and forth. We're going to go side by side, main and thermal, and then while I'm at it, ahead of the delivery, we'll go ahead and switch the recording resolution to 1080p. Alright, so just close out of the SIYI FPV app, reopening up QGroundControl. Now we're not going to, of course, arm it, do any flights in here, not looking to lose any fingers or really any of the objects here. I just realized I wasn't recording from my proper microphone audio as well, so pardon, we're going to have less than ideal audio recording through my computer for the first however long we've been recording. Let's see. Shows I'm disconnected. I got set up with this, but alright, no, I got muted. Let's see. Shows how competent I am, right? There we go, I'm recording. And to give our video guy and editor a sync point, there we go. Sorry, Brian, but that's what you get for not coming back for the late night recording session. And trusting me to do it properly. Yeah, right. Still covering the important information, and that's what really matters, right? At least for our customers, and this one in particular. So just waiting for the line to finish going all the way across the screen from left to right, again, allowing the connection to fully establish. And all of the same controls I just reviewed in the SIYI FPV app for the camera are here in the QGroundControl app. So you still have full touchscreen control. Now, we did not get the full set of parameters. So that's been a somewhat consistent problem where you don't get all of the menu options as you're supposed to here in QGroundControl between summary and parameters. So we're going to try rebooting and see if we can get a more solid connection.
GCS Failsafe. GCS Failsafe cleared.
I'm trying to close out of the SIYI FPV app, which has the little picture-in-picture window that you can see opens up. There we go. I think I got rid of it. You don't want that, or at least I don't want it, overlaying on QGroundControl when QGroundControl has the video feed built in. So you can see QGroundControl is not auto-connecting again, so if that's the case, just go ahead and close out of the QGroundControl application and reopen it.
Stabilize flight mode.
And let's see if we have better success this time with establishing a full connection. Jeopardy, folks. Very poorly hummed, or yeah, hummed version of it. All right, but we got full parameters, or a full connection established. So we have the ability to not just set parameters, but also adjust pretty much any and every other setting that we would wish to adjust as well. So I guess just going through this, frame you don't really need to worry about. Again, kind of directed more so at our customer here directly to be able to reference this video. But of course, anyone that wants to build their own developer with a ZT6 system or commission us to build one, we may be interested in doing that again. May not be this exact same setup, but again, reach out to us if you're interested and we'd be more than happy to have that conversation. Nonetheless, you can also just use these ZT6 camera systems on another custom build as well, so it may be helpful there. This is where you can set up and calibrate the radio. That's done ahead of time in this case, so you don't have to worry about that. I think, let's see, that's not switch set. Okay, so this is a switch that we have set channel 5 to use a relay that we have, so you can control the camera with the on-screen touchscreen controls or via Mavlink straight through like QGroundControl, Mission Planner, or our iVue RoboControl application, all of which I'll show you on the computer I have in front of me, which we'll switch back over to once we're done here with the controller. So you can see the flight modes, we don't have any of those assigned to switches, but basically you can set one or more of these switches to change flight modes. This is where you can do all of your sensor calibrations. Shouldn't really need to use the screen all too much. Maybe the compass calibration, really kind of recommend that before each flight, but that's not even something that we always do, and therefore can't really expect our customers to do it. At least that's not what we want to be the case, you know, much like a DJI kind of experience, or of course, ideally even better. It's recommended to do a compass calibration before each flight, but of course not really required. Here's all the battery monitor settings. Don't really need to adjust this unless you're planning on using your own battery. Now, actually, one of the batteries our customer will be receiving beyond this 8,000 milliamp hour battery is a 10,000 milliamp hour battery. This is a 6-cell system, or 6S. And so if you want to have a more accurate battery reading using that other larger battery, you would just change this value here from 8,000 to 10,000. Everything else will stay the same. Motors, we're definitely not going to do anything with this, but you can just ensure that the motors are spinning up as they should be. But as the message here says, make sure you remove all props. We're not going to do that, so we're not going to toggle the slider on. Here's all of your battery fail-safes. So when the battery gets low, it'll smart RTL or RTL, critical action land. Low voltage threshold we have set to 21 volts. That's actually a little bit high with this being a lithium ion battery. We could probably set that to 20 volts, but unless you're trying to maximize the flight, which I don't think will be the case with the customer this is going to, you could actually drop that down to maybe even 20 volts and the critical voltage down to 18 volts. I've seen this system fly as low as like 16.6 volts, at least as indicated through QGroundControl. But that's because the motors and the whole system keeping this developer up in the air, especially with a camera system, video transmission system. It's not going to be the voltage in flight is not going to be the same as the resting voltage once it's back on the ground, and it'll take, a handful of seconds, a few dozen seconds, even a minute or so for that voltage to climb back up after it's been in operation. Tuning, we don't really need to review. You shouldn't have to review that as well. So I think that's it as far as the configuration or any sort of modification you would want to do to the parameters. Now, the other menu options you would want to be aware of, at least for operating developer, are the flight modes. So as you can see here, stabilized flight mode is going to be the default flight mode when you boot up the controller. And you know what? I think if I actually change that here in the flight mode screen, we're going to change that to loiter flight mode. Okay, it doesn't change it there as I thought it might.
Loiter flight mode. Pre-arm.
So
PS1. Bad fix.
Again, you can set the switches up to change flight modes, but then especially for inexperienced users. We find it's actually very common for them to accidentally flip switches and then put it into a flight mode that they don't mean to. So I would recommend, until you get comfortable with this system, just using the touchscreen menu here to change your flight modes. And more often than not, if you're going to be flying with the controller, you're going to be flying in loiter flight mode. And then if you're going to be flying an automated mapping mission, it's going to be in either auto or guided, but the ground control software will take care of setting that flight mode for you, so you don't have to even worry about it. I guess if you were in an automated mission, which we have not gone out and shown you how to do that out in the field yet, we will have another video showing how to do a mapping mission with this developer HP coming soon. You would just go from auto or guided flight mode back into loiter flight mode, and then you would have the ability to resume control with the joysticks here. And as I mentioned, we have touchscreen control here in QGroundControl, at least after I flip that switch. And now I can also zoom in, zoom out. I can recenter the camera. I can also, again, take a photo, record video, all with on-screen buttons. And of course, all that can be configured to buttons and switches here on the controller as well. Now, going over to the computer, we have another way to connect wirelessly to this developer HP. So you can actually have two connections, wireless connections established at the same time, one controlling and monitoring from a computer, one controlling and or monitoring here from the controller. So just a little USB radio plugs into the computer here. Light turns from red to green, showing we are connected. And first of all, we're going to show the iVue RoboControl app. Just select add a drone. We're not going to have GPS, so it's going to show developer's location at the 000 position on the map. And of course, where this was just working, hypothetically speaking, doing a test run before recording.
GPS 1, bad fix.
Let me refresh. There we go. Some bug, I have no idea. Again, we can set flight modes here in the iVue RC app, but probably if you're not going to be flying an automated mission using our missions tab, you'll probably be using the camera control here. Where we can control the gimbal. Now, I think if I go to control it right now, it's not working. And let me just make sure, yeah, drone 1 is selected. However, and so you can see it was actually sending input, but it's not being received. That's the relay switch that we have in here I was talking about. So if I flip this switch, now you can see it took the input from the iVue RoboControl app, and now we're moving the developer's camera with the iVue RoboControl app. And I don't think I'll be able to really show this as clearly as I would like. But you just saw that camera move, and now you're actually seeing me select the movement here via the iVue RoboControl app. So again, you could be operating the developer here with the controller, the MK32 controller, and then be doing camera control with the iVue RoboControl app. We don't have an interface to take photos or record videos yet. That's coming. And then if you're actually streaming the video over 4G LTE, which we're not, you can actually get the video feed back into the iVue RoboControl app as well. Theoretically speaking, we could actually just port this in as a capture card and basically take in the video feed as a USB webcam. And we are working towards that as like a local Wi-Fi sort of radio option, having a limitation built in the web browser. However, 4G LTE or an internet-based video stream is definitely going to be more ideal, albeit, you know, of course, with a data plan. So I think that covers everything on the software side of controlling the ZT6, at least via the iVue RoboControl app and built into the controller. But just showing you, you also have the ability with QGroundControl to have two connections established. And Depending on the QGroundControl version, you may have a different interface, even as just made apparent between the version on my computer here and on this controller. This is actually a SIYI specific version of QGroundControl before they started developing their own ground control software. And then here on this version, we have the ability to zoom the camera. And then we have the ability to, let's see, does that just take a photo? It doesn't even give any feedback, so I don't even think this functionality works. So if you want to do any camera control, you'll actually, or photo capture, video recording, you'll have to do that from the controller, but the actual gimbal control you can do here from QGroundControl. Now Mission Planner, I think you'll actually have the ability, and there could probably be some setup or configuration to enable camera operation, not just gimbal operation, via this instance of QGroundControl. But I don't think that will be required again for our customer specifically, but our customer or anyone else watching, if you have questions about how that can be done, let me know, and then I can at least have someone on our team look into it, and likely I'll be the one reporting back. Going over to Mission Planner, I'll show you the way you can control the camera there. There was another camera interface I kind of glossed over in QGroundControl, but the functionality is fairly limited, hence why I glossed over it. QGroundControl did not quit unexpectedly. I quit out of it. And actually, while I haven't mentioned it specifically, if you want, you don't have to use this MK32 controller at all to fly this Developer HP. Again, you may have some limited functionality, but all you really need is this radio. And then to some degree, maybe not to the most intuitive degree, at least in its current state, have the ability to control everything from the gimbal, the camera, to the Developer flight itself. Again, all without having to use this MK32 controller. If I go to payload control, you can see here I have tilt and pan control. And let me just switch back over to the controller view so you can see that once again from the controller view. In Mission Planner we have tilt and pan. So fairly seamless. Again, not the biggest fan of QGroundControl or Mission Planner, but they do have some functionality we just don't in the iVue RoboControl app, at least for the time being. So bear with us as we develop out a more intuitive option to control Developer and these sorts of payloads, including this ZT6 camera. But I think that's it actually completely across the board on the software side. So we can go ahead and unplug this Develop Air HP. I think we'll go ahead and flip back the relay switch, and I'll be covering that here in just a moment as we open up the top cover. And as I mentioned, turning off the controller, just power off, holding down this top middle button here. And then to power it on, it's actually a short press and then hold down long press. So opening up the Developer HP, it's actually a fairly clean build. It may not look like it on camera. Hopefully that's somewhat visible across the two camera feeds that we have. We have a 4-in-1 ESC. We're using a FETtec 35 amp 4-in-1 ESC. If you've seen me post about this Developer HP over the last couple weeks or so, you'll know that this has been quite the learning process and quite the experience in getting this Developer built out in a way that I'm actually maybe not even proud of, but I guess happy enough with. And I would say it's definitely a great build as far as everything that we have to work with. But of course, me just wanting more of a prosumer drone product in the market, You know, I'm my own worst critic. But nonetheless, I think our customer is going to be very happy with this build out, albeit many, many months later than I think we would all like it to be. Luckily, you know, I think they were just using it more as a demo or prop to get students excited about their program more than anything else. Nonetheless, you know, we do want to make sure it's reliable, completely functional, and going to do the job if and when it's required of it. So nonetheless, we talked on the 4-in-1 ESC that's hidden underneath the Pixhawk flight controller. We're using a Pixhawk 6C flight controller. As I mentioned, we have a relay switch set up. I don't know all the technical specifics about how that operates, but essentially, again, it just allows you to go between Mavlink control is what we're calling it, and then the touchscreen serial or UART control. That's built into like the video transmitter. So there's one control system that goes through the video transmitter, and then one control system that goes through the flight controller. And I think I should be able to kind of figure this out on the fly, given I'm not exactly the quote unquote engineer who sets all of this up. I do a lot of the building, again, more production technician than engineer developer. But again, we each have our parts of the team, and this is mine showing it all off. As non-ideal as it may be for you more technical viewers out there, all dozens of you. So here from the camera itself, the ZT6, we have that going into the GPS 2 port, which is the serial 4 port on the Pixhawk 6C. So you can actually have that going to any of the telemetry ports as well, but we have all 3 telemetry ports taken up, one via the MLRS radio plugged into to telemetry 1, and telemetry port 2 we have the video transmitter system, and then telemetry 3 we have the FETtec ESC. Instead of running PWM or D-Shot or BD Shot or I think there's a couple other more universal or standard ESC telemetry standards, we're using FETtec's proprietary telemetry called One Wire, which is actually using 3 wires, 1 ground wire, 1 telemetry wire, and then one wire for all 4 motors, being a quadcopter. And then we have our side plate system here in the rear, where you have the ability to connect additional payloads, retractable landing gear, as I mentioned in our last flight video with this developer, HP. Again, that's not equipped on this build, but our customer could upgrade it, could commission us to upgrade it, or of course, if you're wanting to build one similar to this, you can make sure you have landing gear that get up and out of the way of the gimbaled camera, you know, which is able to rotate around. And if you don't want that landing gear in the shot, then, you know, retractable landing gear. It maybe not the only option, but, you know, one of the better options out there. I think that's really everything inside there that you may have questions about. I think it's a pretty straightforward setup. I think we did have to make some of these cables in-house. I don't know if that was due to losing some that we would have gotten from SIYI otherwise, but nonetheless, we had all the crimped wires necessary to run those. And I think some were required to be longer, which it may not be apparent, but there's actually some pass-through holes that the wires go through. Let me see if I can get another fuselage here. So on both sides of the fuselage, there's wires that we run all of those wires from the ZT6 and the video transmission system up and through the fuselage without having to wire them around and through the sides. And I think, yeah, everything else is not really necessary to cover. We have a couple of BECs running in here. We have another open connection for a BEC to run peripherals that aren't running from the 5-volt power rail. We have our LED adapter board, but that's standard across all of our developer models, not anything really unique to be covered from this build. And getting the top cover back on. This is a newer GPS that we're using, and unlike the other GPSs, it comes with this little plastic piece and actually quite a bit longer of a cable than what would be ideal for develop air, but nonetheless it's a high performing GPS otherwise, and so roll with the punches. And if you gotta deal with a little bit longer than what is ideal of a cable, then so be it, right? All right. And then I guess more just physically reviewing the setup here. If you want to see the underside, I'm going to have to start this camera again that stopped rolling. And have to resync audio for the editor. That was a wimpy clap, but should have got the job done. And so you can see the underside where we had the video transmitter installed, the ZT6 here installed right in front of it, the antennas running by the landing gear legs. So maybe not, again, a DJI style vertically integrated clean build, but compared to the most open frame carbon fiber plate builds, I think looks pretty damn good. And then just the power, we have split between the ZT6 and the video transmitter going to a Y adapter. So it's just this one cable. So you can actually, and this is how I recommend it for a customer or anyone else that builds a develop air or buys one like this in a similar configuration. You actually just keep the power connector into the develop air HP as well as the video transmitter and camera, and then you just unplug it where the battery plugs in. And then you could always just charge, as I have done in many cases with this develop air HP in particular, just even leave the battery in and then take the charger to this develop air HP, and becomes a lot easier if you're not wanting to switch batteries like in between flights, just keeping this one battery in and charging it with the battery installed. I think that's a pretty, maybe not comprehensive overview of this build, but at least a good overview to get started. Again, mostly for our specific customer of this specific unit, but hopefully it helps some of you else out there that are interested in building a develop air beyond just flying it with a gimbal camera payload, whether it's this ZT6 or otherwise. We think this is a fairly good option. I do know that there are, kind of less expensive options out on the market now, since we had originally procured this ZT6, but I would say for what it's worth, a Chinese gimbal camera system on American drone is about as good as it gets right now, until maybe we can get that partnership with Sony dialed in or locked in, I should say. But short of that, I think this is it for this video. Again, if you have any comments, questions, or concerns, leave them down in the comments section below. Otherwise, appreciate you watching and stay tuned. Peace.